backyard cannons, tanks, and an innovative spherical robot.
My fantasy goal is to basically just be an inventor.
We'll talk to an inventor with big aspirations and the inventions to match now on The Circuit. Welcome to The Circuit. Our ongoing journey to bring you the nation's brightest young inventors takes us to Fort Collins, Colorado. Here in the shadow of the Rocky Mountains lives a mechanical engineer who's designed a spherical robot with the potential to navigate the toughest terrains. Meet Greg Schroll. He's a 23-year-old that grew up with an interest in tinkering and a talent for invention.
My main inspiration for even pursuing mechanical engineering in the first place was my dad. He kind of drove me to pursue ideas on my own and try to experiment and tinker.
By high school, Greg's talents began to take off. Building backyard cannons and an all-weather tank became fodder for developing a palette of advanced engineering skills.
In high school, I built some pressurized air cannons. I learned about pressure and forces and things in physics, and I needed that in order to actually understand what was really going on behind the construction of these air cannons and building valves and everything like that. So I realized that I learned all this stuff in school, and wow, I can actually apply it to this fun project I can build.
Upon entering MIT, a growing engineering prowess would be put to use in both the lab and the dorm. While having a ball, Greg won MIT's top undergraduate prize for invention with an innovative robotic sphere. All right, Greg, what is this ball here?
This is a spherical mobile robot. It's basically a ball that can roll around any which way it wants to go. It has enough torque that it can actually climb stairs and go over rugged terrain and everything.
Very cool. Can you show me how it works?
Sure.
All right. The innovation is the creative use of gyroscopes.
The spherical robot that I built incorporates gyroscopes. Gravity is going to be pulling down on the gyroscope, which is going to try to tilt the spin axis this way. It's going to apply a torque to tilt the spin axis this way, and it will react by moving this way. So it reacts in the third direction, and so it actually rotate around. So if I let go, it precesses around in a circle instead of falling straight down to the table. Whereas if this were not spinning at all, and I did the same thing and I let go, it just falls over.
So how do the motors inside work to get it to move, to roll, and to turn?
Basically, there's two drive motors. It almost works kind of like a tank drive where you have two treads, and if you drive them together, you go forward. And if you drive them opposite each other, you can turn.
Right.
So in this case, it's similar, but instead it uses a differential. So if you actually drive the two motors in the opposite directions, it goes forward and backward. And if you drive them in the same direction, it causes the pendulum to tilt to the side, so you can drive in an arc. It uses just battery power. Basically, most of the components in here are RC car parts, like the motors are RC car motors, and the batteries are too.
It's amazing, but what would it be used for?
There are advantages to this design versus like a four-wheeled off-road vehicle. It could be applicable to planetary exploration or search and rescue, hazardous environment assessment, surveillance, reconnaissance, that sort of thing. As I learn new things, I'm constantly exposed to all these things I don't know. And as I think of new ideas and pursue new things, I have like a billion new ideas based on that. My fantasy goal is to basically just be an inventor and have the resources to just tinker.
Well, as you can see, Greg is definitely on a roll. As he waits on a patent for his new technology, he continues working towards his doctorate here at Colorado State, and of course, climbing new heights of innovation. Well, that's it from the Rocky Mountain State. We'll see you next time on The Circuit.